Okay, here we go. End of chapter 1. This last lesson is meant to be just kind of an introduction, so we start to talk about some three-dimensional shapes. When we get to chapter 12, we will be talking much more about three-dimensional shapes, going much more in depth. So don't worry about it if this does seem like a lot of information. We will go more in depth later on in this class. This is just meant to be more of an introduction. So, first piece of vocab is polyhedron. Poly, again, meaning many. Hedrons would be faces. So, a polyhedron is going to be a three-dimensional shape where every face is a polygon. Every face is a polygon. So, what is a face? A face is the two-dimensional shape. Faces intersect at edges. Edges would be a one-dimensional line segment. And then edges all intersect at the vertices. And those would be zero-dimensional points. Some different types of polyhedrons that we're going to be looking at. The first one is called a prism. A prism is a polyhedron with two parallel congruent faces, and those are called bases. I don't expect you to have all of this stuff and draw all of these pictures. This is, again, just more meant to be an introduction, and we'll get more into this stuff later, and in chapter 12, I'll teach you guys how you can draw these. So in this polyhedron, it has two congruent bases, where these faces are congruent. It would actually have the two bases and then 5 other faces around it. So this one would have 7 faces. Looking at these other words, this word edge would be like the two-dimensional line segments. So the edges here would be all of these line segments that are shown. You can see some of those line segments there. And then these vertices would be like the points or the corners. All of these would be vertices for this prism. Okay, the next word is pyramid. A pyramid's the polyhedron. So again, all of these faces are polygons that has a base, but then it doesn't have another base that's parallel to it. All of the other triangular faces meet at one singular vertex, and that's what makes it a pyramid. So this is like the type of pyramid that you would see in Egypt, but we're going to find out that there are other pyramids too. Okay. These other 3 shapes are not polyhedrons because not every face is a polygon. Like in a cylinder, this face here, or this part here, is a circle, and a circle is not a polygon. So a cylinder would have 2 circular bases, and then it would be connected together by this curved surface that we would see around here. A cone has a base that's a circle, and then one singular vertex with this curved surface that would go around it. And lastly, a sphere, you've probably heard this word for years now, has no faces, edges, vertices. It's just like a ball. It's a set of points that are all equal distance from the singular point. You know, they would all have that same radius. Okay, I wanted to show you here some different types of prisms. The way we name a prism is we always name it by its base. And pyramids, we always name those by its base too. So I'm just going to write prism pyramid named by its base. So in this triangular prism, the bases are not always the side that it's sitting on. The bases are the sides that are congruent and parallel to each other. So this is called a triangular prism because the bases are triangles. In a rectangular prism, the bases are rectangles. And really, in a rectangular prism, you could call any parallel sides the bases. So if I wanted to call the bottom and the top one bases, I could. I could even call like this side here and this side over here bases because they're congruent and parallel to each other. Or even the front and the back, if you thought of this as a box, could also be considered bases. In this pentagonal prism, the bases are the pentagons. We could have octagonal prisms or hexagonal prisms. We would just name it by whatever the base is. Okay, in a triangular pyramid, the base is a triangle. And then all the other faces are triangles too, and they all meet up here at the singular point. A rectangular pyramid, or you could even have a square pyramid if that rectangle was a perfect square. The base is a square. Pentagonal pyramid, that base is a pentagon, or you could have a decagonal pyramid or an octagonal pyramid, all sorts of different types. Okay, I'm going to change some of the directions that are found in your book so we don't have to have answers that are like a half a page long. I'm going to have you guys change these directions to just tell me how many bases, faces, edges, and vertices there are, and then I'm going to have you name what the base is too. So when you see directions like this, it says determine whether it's a polyhedron. So yes, this first one is a polyhedron because all of those faces are polygons, meaning there's no curved sides. That's really the main thing that you're looking for. Identify this solid. This solid would be a rectangular prism. If it is a polyhedron, then we need to go through and name the bases. So instead of naming those bases like they did over here, like R, S, T, Q, and then the other one also, I'm just going to have you name that the bases are rectangles. If you would like to go through and name those two different rectangles, you could. But just so, again, we don't end up with like a whole paragraph of different answers, I won't make you do that. And then for the other ones, for the faces, the edges, and the vertices, I'm going to have you just count up how many there are instead of naming every single one. So the faces, there's the top and the bottom, and then there's 1, 2, 3, 4 around the outside. So there are 6 faces. The edges, remember those are the line segments. So if I count those, I have 1, 2, 3, 4. And then I have 4 more around the top face and 4 more around the bottom face. So that gives me 12 edges. And then the vertices are the corners or the places that those edges come together. So there would be 8 vertices. And again, the book has them all listed out. If you would rather do that, that's fine. I think this, we can kind of get that same concept without having to get a cramp in our hand. Okay, the next one here, the directions again, remember, say determine whether each solid is a polyhedron. This is not a polyhedron because of these curved circular sides. This would be called a cylinder. And because it's not a polyhedron, we do not need to name anything else. So you'll like the ones that are not polyhedrons. You can just say, no, it's not a polyhedron, it's a cylinder, and then be done. For this last one here, yes, it's a polyhedron. It's a triangular prism. I'm sorry, it's a triangular pyramid. I already messed that one up. So pyramid. And it has 1, 2, 3, and then the bottom face is 4. 4 faces. Oh, I'm sorry, I forgot to tell that the base is the triangle. So 4 faces. It's going to have 6 edges and 4 vertices. And again, you could just write the number of how many there are instead of having to list everything out. Hey, I included this snapshot from your book. If you do not have one of these already, you need to get one from me because I will not be requiring that you memorize all of them. When we get to chapter 12, I'll give you kind of hints as to why these things are what they are. But for right now, you're just going to get a copy of this. You can use it on the test, and it's going to tell you what every thing stands for. It's also going to give you all the formulas, so don't feel like you have to have all of these memorized. I'm going to ask that while I do this next example, you have this chart out so that you know where I'm getting these formulas from, and that will kind of help you follow along. As I go through the examples, I'm going to also ask, along with this chart, that you have a calculator out so we can make sure that you're typing these things correctly into your calculator. Okay, so before I get started though with the examples, just pointing some things out on here. This capital letter P stands for the perimeter of the base. So that might be something that you need to solve for first, because you're going to need to know that for a prism. You're going to need to know the perimeter of the base. So if it's like a triangular or a rectangle or a square, you'll have to calculate that out first. If it's in a pyramid, the base is this here. You're going to have to calculate that perimeter first. And we're just going to be looking at regular pyramids. So this would be a square, even though it might look like a parallelogram or a rectangle. Something else you need to know, this capital B, when you see a capital B in the formula, which we see in a lot of different places. Let's see, it's here and here. Capital B stands for the area of the base. So just like perimeter of the base, where you might have to calculate that out first, area of the base is going to be the same thing. You might have to find the area of this rectangle or the area of this square. For the next little nuance, you're going to need to know the difference between slant height and height of the solid. And this will only take place with the cone and the pyramid. So the slant height is just kind of what it sounds like. The slant height is the slant height, the height of the slant. And the actual height, it would be like straight up and down how tall that object is. In this pyramid, the slant height is labeled here. The actual height, they don't have that on there, but that would be part of this middle part, and it would be going straight up if they wanted you to find the actual height. So you can hear my kids in the background. Let me go and shut the door quick. There we go. So for these next examples, again, please make sure that you have a calculator out, and we will get going with them. So the directions are going to ask you to find the surface area and the volume of each of these shapes. So I abbreviate surface area with SA. The book just uses the letter S. That's just a personal preference. That's not going to really matter too much. So what I would do first if I were you is I would locate on that formula sheet what shape this is, what type of polyhedron this is. This one here is a pyramid. And what I would do then is I would write out the formulas. So the surface area of a pyramid is half the perimeter of the base times the slant height, plus that capital B, remember, stands for the area of the base. And volume is 1/3 the area of the base, and this one has an H, and that's the actual height of this pyramid. So before I do anything else, I'm going to go over here and I'm just going to calculate what the perimeter and the area of the base are so that I have those numbers to work with, and that will make this question really easy, just plugging numbers into the formula after I figure out what the perimeter and area of the base are. So because this is a regular pyramid, and all of the ones that we're going to do right now are going to be regular pyramids, that means that this is a regular shape, and since it has 4 sides, it's going to be a square. Because remember, regular means all the sides, all the angles are the same. So if I wanted to find the perimeter of this square, I would just be adding up all these sides, or you could multiply 6 times 4. the perimeter would be 24 centimeters. And then the area of this base is going to be its length times its width. So that's going to be 36 square centimeters. And I'm just going to worry about units at the end. That's why I didn't put them on here. But I think it's very helpful to you maybe to write these things out. So then when we're going through these formulas, we're just plugging the numbers in. So surface area is half the perimeter of the base, which we just found to be 24. L stands for slant height. So the slant height would be this height of the slant, so that's 5, plus the area of the base, which is 36. And I'm going to ask that you grab your calculator and just make sure that you can type this into your calculator correct, so you're not doing all the work right and then getting the wrong answer. You should get 96, and units for surface area are going to always be square units because we're talking about the area of all of the surfaces added together. Okay. I know I'm giving you these formulas, but remember you could always find the area of all 5 of these surfaces, the area of the rectangle or square on the bottom, the area of all 4 of these triangles, and just add them up, and you would also get 96 square centimeters. Volume is 1/3 the area of the base, which we calculated to be 36 already, times the height of the pyramid, and in this case the height is the straight up and down, so that is 4. So when I multiply these things together, I get 48, and units for volume are always going to be cubic. So that would be centimeters cubed. Okay, before we get into, okay, I'm making the video. You need to get out, please. Okay, it's my kids again. They just finished watching a movie, and now they're all in here, and you might be hearing them a little bit more. Okay, so before we get into this next one, I have joke of the day. How many tickles does it take to make an octopus laugh? Tentacles. Okay, for this cone, we want surface area formula, and just remember you can get this right off your formula sheet. So the surface area is pi r times the slant height plus pi r squared, and volume is 1/3 r squared, so radius squared, times the height. And you'll like these that have a circle with them because you're just picking the numbers out. There's no extra calculations that you need to do first. You can just plug the numbers right into your calculator. So in this case, it's going to be pi times the radius, which is 15, times the slant height is 17, plus pi times the radius, which was 15 squared. Just make sure right now you grab your calculator and type this in. If you need to pause it to type it in quick. We are just going to round this to the tenths place. You should get 1,508, and this would round to be 0.0, and that's going to be square inches. If you're rounded to the tenths place, even if it's a 0, it's proper notation just to write that to show that it's been rounded. And then for volume, we have 1/3 the radius, which is 15, so 15 squared, times the actual height now. So the actual height's only 8. And when you type that into your calculator, you should get 1,885. And this also just happens to be 0.0. And volume's going to be cubic inches, or you could say inches cubed. So there's a couple more examples I want to do with you. The next one is a cylinder. So surface area formula for a cylinder, we are including both of those circles and the distance around. So it's 2 pi rh plus 2 pi r squared, where the height is 18 and the radius is 6. So for surface area, I'm going to plug in 2 pi times the radius 6 times the height 18 plus 2 pi times the radius 6 squared. And just type this into your calculator to make sure you're getting it. If you need to pause it, that's fine. The answer that you should get is 904.8, and that's square feet. And for volume, the formula is pi r squared h times the height. And this is going to be pi times the radius 6 squared times the height, which is 18. And grab your calculator again, type it in. You should get 2035.8, and that's cubic feet, or feet cubed. Okay, and then last but not least, our rectangular prism. It's so important that you pick a base. And for rectangular prism, it doesn't really matter. You're going to have an example that is a triangular prism. For the triangular prism, the base has to be the triangles. Okay, but the base for this one doesn't matter as much. So if you want to call it the bottom part, that's fine. If you want to call it a different side, that's fine too. I'm going to say that this is my base. So when I find the perimeter of this base, I'm just going to add up 5.2 plus 10, 5.2 plus 10. So the perimeter of this base is, let's see, that's going to be 30.4. The area of this base is just multiplying those two dimensions together. So when I multiply those two dimensions together, it's going to be 52. And if you do this work up front and you just have these numbers written out, it's going to make plugging these numbers into the formula a whole lot easier. So you're not having to go through and remember, oh yeah, what does P stand for? What does B stand for? If you just do that work up front. So surface area is 2 times the perimeter, 2 times the area of the base plus the perimeter times the height. The book writes that differently, so that's the way I wrote it. It's just not the way I'm used to saying it. Okay, so this is my perimeter of the base times the height plus 2 times the area of the base. And when you multiply all this stuff together, you should get 286.4, and that's centimeters squared. If you would rather, for surface area, again, just calculate the area of every surface. So in this case, calculate the area of every rectangle. That would be perfectly acceptable too. So if I found the area of this bottom rectangle, which would be 52, I could just double it because this top rectangle is going to be the same. Same thing for this side here. If I find the area of this rectangle by multiplying 6 times 5.2, I could just double that for this one. And then lastly, if I want to find the area of the front and the back, this front one, I would multiply 10 times 6 to get 60, and then add that to the back one. And if I add all of those faces together, I'll get that exact same answer. So for rectangular prisms, it might be easier for you not to use the formula, but I wanted to show you this formula because as we go throughout this class, it'll be easier, I think, for you to use when we get to pentagonal prisms and octagonal prisms towards the end of the year. Okay, and then lastly, the volume. The volume of a rectangular prism, you might have learned before, you can just multiply all 3 dimensions, but I'm going to show you how to use this formula. So the formula is the area of the base times the height, which is 6. Remember, the area of the base we got by just multiplying these together. And then when I multiply that by 6, I get 312. And that's centimeters cubed. So either way, you're either just multiplying those numbers together first or at the end. For a triangular prism, remember the area of the base is going to be the area of the triangle. So you'll have to do half the area, so half base times height when you find that one. So I hope this was helpful. We will do a lot of practice of these in class, and just make sure you're kind of checking your work, and I can help you if you get stuck. I will see you guys soon.